Hi everyone, my name is Sriram. I'm having total 15 years of IT experience. I'm a certified Azure Data Engineering Solution Architect. I do provide the trainings on Azure data engineering skills uh, like Data Factory, Data Bricks, Data Lake Storage Gen 2, advanced services like Synapse, Event Hubs, IoT Hubs, Stream Analytics. I do also provide guidance and training for the upcoming students who want to transition from traditional data warehousing to the cloud data warehouse, predominantly in Azure. So far, I have given a 50 plus kind of sessions to multiple students. So more than 50 plus students have already transitioned into this kind of technology with the help of.
Right.
Let me know if you're able to see my screen.
Yes.
Okay. So today we are here to go through the one of the demo related to Data Factory. So basically, Data Factory is a kind of a ETL tool on Azure cloud where it will do all the kind of data ingestion, data movement, followed by the data transformations. It has all capabilities in the cloud area, like Azure SSIS, right? SQL Server Integration Services in the on-premise, where we have the ETL workflows on the on-premise, right? Similarly, this is a kind of a cloud version, predominantly working with Azure because it's a Azure native patch services, where it has kind of a capabilities, data ingestion, transformations, and loading back to the target. So this is a kind of a plug and play GUI kind of ETL tool, but it is not limited to only that option. We have customized scripts we can develop based on the requirement, and we can also integrate multiple activities in the flow to get it into the based upon the need of the use cases. But it has its own lot more capabilities to do these kind of data moments and the copying, transformations, everything. So let's get into details. Okay, first let's introduce about why we are going into the cloud. Actually, we have so much in the on-premise, right? We have Informatica, we have data stage, we have something else. So many ETL tools are there. So why we have to go into the kind of a specific to the cloud PaaS native service in Azure? So I'm moving on to other slide. One second. Stuck up. One second, my screen got stuck. Okay. Okay. So many of you knows about this cloud computing. Let's give me 2 minutes about cloud computing. So let's move on from left to the right. So where in the left is a kind of a where we are all currently working in past, and we are also still working on the on-premise environment where we need to take care of all complete responsibilities from the to manage everything, storage, network, or OS, or runtime, data, and application software. Everything we need to own. So there is upfront cost involved to set up this kind of environment and to maintain it and to extend it based upon the peaks and based upon the need of the business time. So it may not work in this kind of environment right now, where we don't have any, if we have any predictable data load on particular period and all, right? So we don't have any ability to scale up or a scale down or a scale out or a scale in as elastic as we get in the cloud. So that's where we are moving on. All people are moving into the cloud. So predominantly we have three different categories. One is IaaS, second one is PaaS, and third one is SaaS. Let me tell you the difference of these three. The first one is a kind of all the server, storage, networking, everything virtualization managed by the CSP. When I say CSP is a cloud service provider, it could be Amazon, it could be Azure, or it could be GCP, or it could be something else. So on top of the orange color, where we will take care of the responsibility, like setting, installing the software and patches and application data, everything will take care. So that is one kind of a deployment in the Azure, in any cloud model. Similarly, PaaS service. What more? We have so much extraction on top of IaaS, where we will only work with application and data. All the runtime, middleware, OS, everything behind the scene will take care of by the CSP. Similarly, last one is a SaaS, software as a service. So where we have everything completely managed by the CSP, and we will go and work upon the directly with the software like Salesforce or OS 365. So our data, I'm giving this background to understand where our ADF will fit. So ADF will come and fit into the platform as a service, in the middle one in the cloud. So where we have all the management of runtime middleware, everything servers done by the CSP, where we will be writing only our application code and we will connecting to the data and we will take care of the further. So ours is a PaaS service, platform as a service. Okay. So I'm moving on to the slide. So these are the common predominant public CSPs in the market right now. Out of these four, majority is AWS, followed by Azure, followed by the GCP. So we have IBM, Alibaba, Oracle, some lot of things are there, but these are the leaders, these three: Amazon, Azure, and cloud. So every cloud, it has own native PaaS services to do this processing in the data space. So, okay, let me quickly jump on to directly into ADF now. See, as I given the definition, what is ADF? Let's understand what are the critical components and building blocks involved in ADF, and followed by the architecture, how it works. Okay. So data factory, it's a kind of a PaaS service where it has critical components associated with is, to start with, pipeline. So many people know, right? Some people may be knowing it. Some people are trying to understand what is pipeline. We'll get into the detail in the further session. But to make it simple, pipeline is a kind of a chaining of all the small activities in one go, so that it will be automatic way. All the activities will get executed one by one based upon the dependency. So this pipeline will be deployed for the production usage once we are done. So that is the meaning of the pipeline. Followed by the activity. So activity is a kind of a task which perform in the process of creating the pipeline. There are a couple of activities like selecting, merging, filtering, and or to do some kind of additional things. That's everything we can achieve using this small different activities, and we will all chain them together to create the pipeline. So in a short, pipeline is a collection of activities where activities is kind of to perform some task. It again subject to the requirement use case, what we are trying to do that activity using your work. Followed by link service. So link service is a very critical component. Why? Because this is the capability where we can go and connect to the it holds the connection string to connect to the systems, be it a source system on premise, or it could be another cloud on the private public area, or it could be on the same Azure. So we have different ways of how we can connect. Without connection, we cannot go and bring the data, right? So it holds predominantly the connection string of the respective system. Then the important one is a data set. See, data set is it, we know the system, we know the connection, how to connect, but we have something metadata or a data format, right, to understand ADF, how to understand the data to proceed further. So that is the representation of the data which will be taken care by the data set. So we have all the components: pipeline, activity, link service, data set. We have source, and we know how to connect, and we know what is the format via data set, and we know whether we need to copy or we need to filter some data or we need to shape any using activity. After that, we can combine all the activities we form pipeline. All is there, but how this will behind the scene it will execute? If you have Informatica data state, something we have servers, right, where we can install, admins will come and support you to give that environment, and some computation is required, right, to perform all these activities. But how we can achieve in the ADF? So we have a kind of an integration runtime. This is very, very critical component. This basically, without this, it is just a skeleton. It will not do anything. With this integration runtime only, all the Azure Data Factory building blocks will get a computation power to go and execute the task. So everything will be done as a kind of a serverless kind of, it's not exactly serverless. What I mean to say that you are not going to create any cluster, or you are not going to create any server to execute these tasks. The moment you want to create integration runtime based upon we have a couple of 3 types of integration runtime based on use case. So we need to identify, we need to select. That will basically give the computational power to go and perform the task. So without computation, nothing can be done, right? The power, this will be given by the infrastructure runtime. See, everything is there, but how we can achieve all the predominantly we have data movements, everything, right? So we have something called copy activity. I didn't mention here. That is one of the very prominent activity. We frequently use it in any of the project, in any of the program where we are going to work, because that is a very basic need to move the data into a specific folder. So that will covered by the activity. I didn't mention it. That is a kind of a copy activity. And the critical point, how we can achieve, we are talking about, right? It is a drill and drag. There is a code is not required, right? So that's where we can achieve it through the data flow. This is not pretty new. It is new compared to other areas, but it is evolving it in its own direction, and a lot more capabilities they're trying to add it here. Data flow today has a lot of transformations in it to do it based upon the requirement, but it has more capabilities are getting added day by day in any other ETL GUI tool, right? So if any complex transformations we could not achieve by data flow, so it could be anything in data stage informatica. Also, we used to go for some custom solution, right, where we will write some script in a SQL we can execute. So it has its that capability as well. We will get into that once we go there. Data, these are the critical components. So the most of the understanding of ADF will go through on these activities predominantly. These are the fundamental blocks. So I'm moving on to with the same components. Let's jump onto the architecture, how it works, ADF. So this is the kind of architecture which I told you, right? So let me go through it one by one quickly again. So we have a top pipeline. So this is what the pipeline I told you, right? Pipeline is nothing but a collection of the activities, where we have the activity called, here we have only one activity. Like that we could have different activities. We'll change them in a single pipeline so that we can do it very robust dynamic pipeline in the ADF we can execute. So we have one activity called copy activity. So this copy activity want to bring the data from left to right. So left is a kind of a blob storage, right is a kind of a SQL server. The use case here in the architecture they're talking about how we can we will get into the more details when we get into the classes of what is blob storage and what are the SQL servers. So let's understand, this is something, source is a blob, there is a file where you need to, using ADF, you need to bring the data into, load into SQL server. So that is your use case. So what we talked about, all the components, right? With this only we can achieve this one, with that only. Like we have talked about, pipeline is there, copy activity is there, we know the data set, we know the link service, it has the connection string of the blob. This here target said we have the connection string of the SQL server, and we have the data set representation. See here also data set source, and we call target as a sink in Azure predominantly. Here we call source. So this is in CSV format. So these are the activities, get table list for each activity. These are the couple of activities we can call it in general category in Azure Data Factory. So with this, we can achieve all these transformations. So on top of all this, missing is integration runtime. So without integration runtime, this cannot be run. That's what I think that is missing here. Just I want to show a little bit more about architecture. So it works on kind of environment where we need to chain all the activities. So for every activity, we need to ensure that what is source and what is target, intermediately what is the connection string we need to give, what is the format of the data set, we are kind of metadata, because some could be blob and some could be sources, it could be any number of. Currently ADF is supporting 90 plus connectors. It could be on premise or any of the cloud, so it has the capabilities of 90 connects where we have natively go and connect to the system to bring the data. So predominantly multiple projects will work, most of the data transfer data movements will happen through CSV. So that's the reason we highlighted CSV file here, but it is not only restricted to CSV file, it could support multiple formats. We'll get into there once we are there. Okay. So this is the critical architecture. See, one more thing, I'm talking ETL tool, I'm talking ADF in a ETL way only, right, so far, but it has capabilities to orchestrate. So like workflows, right? In any of other cloud ETL, it has the capabilities to chain the pipelines, and to using a triggers, we can schedule it. We can chain all these blocks, and we can achieve it as a single one-stop solution to do the orchestration. So that in the production, once you deploy, we can create a robust data flows, robust workflows using this ADF, and we have all the monitoring capabilities, alerting mechanism, everything. It will act as a even orchestration as well, along with the inbuilt ETL, ELT capabilities. So this quickly I want to show, this is the kind of data sources with ADF. I can bring it to the staging with the blob storage using data flows. These are the built capabilities, sort, merge, and which I was talking about. Using data flows, we can achieve this, do some transformation and load back to the destination based upon use case. It could be database, it could be data warehouse, it could be again data lake, based upon the need of this modern environment. Okay, so this is the quickly about the orchestration one. Okay, let's go into the demo. Enough theory is enough. Let's jump onto the theory, and we will take the questions at the end. So right now, this is the kind of a portal, Microsoft Azure portal. I'll quickly run through. So it works in a like any of other cloud, right? GCP or AWS. Similar way, the names will be changed. So I'm not getting into that in detail about this, explaining about Azure cloud, but quickly run through how it works. See, basically, Microsoft works predominantly on the subscription point of view, because the work you need to start using with subscription, underneath, we need to create a resource group. Resource group is a kind of a logical container to hold all your services, because you will create one kind of a pool of resource group where you will procure all your services and put it into that container. So in this case, I created something called STGREG. This is a resource group. So within that resource group, I created one storage account and one data factory workspace. So I'm just going there directly, data factory. So data factory, it's a kind of a workspace we are going to create. So within this workspace, we are going to open the studio where we will do all the kind of development, everything, right, which we talked about. For that, we need to go into the data factory studio. So this is where data factory looks. So there is a very good documentation available over the internet for every use case, and it talk about some how to ingest, orchestrate, transform data. If you want, you can go through it. But predominantly, we have 4 sections: home, author, monitor, and manage. So let's go into the author. So I'm talking about some components, right? The pipelines, everything. So here is the area where we will be going and creating the pipeline. So just to create a new pipeline, I'm just showing some simple thing. So this is the area, move and transform, which I told you, right? Activities where we have copy activity for the copying moment. For transformations, we have data flows. Once we get into session, we'll be in detail about data flows. Apart from this, it has other capabilities where we can make use of based upon the use case. Because if you want to write some Azure functions, how we can chain it in the data factory. If you have any Databricks kind of a notebooks, if you want to write in the Spark code, and if you want to integrate with ADF, we can do. And if you have any data like analytics, if you want to do some kind of a SQL kind of a stuff to get the data using, you can write a script, we can execute it. Similarly, I talked about general, right? Like lookup, stored procedure, validation, web activity. These are general during the shaping the data, we will be using it predominantly. Similarly, if you have any HT insight where we have Hive script to be run or a Pix script to run, Spark, streaming, everything we can achieve. Its list is evolving. Iteration and conditions, if you want to filter for each if conditions, which we can make use. Some of the machine learning capabilities also we have it here. Similarly, Power Query. This is for, I think it's related to Power BI, but I'm not sure. I have to check on this. There's something new which I need to explore. Okay, so most of our work will end up in doing this first move on transform, where we'll cover the data ingestion and doing all the transformation. But if any complex transformations, if you cannot able to achieve in the ADF, or if you feel that it is a very tough to manageable, where we will go and do some kind of a coding in the notebooks and Databricks, and we can attach it based upon the requirement of the project. It's not recommended everywhere we need to write a code. There are multiple projects where we will do only migration, and we will do kind of transformations using this two itself. So our course will target mostly on this move and transform, and some introduction about Databricks, because based upon the interest of the team, we can still go and work about some use case on Databricks. So most of our work will talk about all the things we'll cover, and most of the activities will be related to the copy and data flow. If you go data flow, there is a lot more things are there. We'll go there one. So this is the pipeline. So I'll try to simulate the same scenario, right, which I've tried to show you, right, but slight change. So I have a blob storage instead of that SQL Server target. I will do some kind of a copy and transform back to the same blob again. The only change is that here is that without SQL Server, I'm going to put a blob storage only. So let's try to see how it works actually. So as I told you, right, I have a kind of a storage account already I created. Let's go there. So this is my storage account. Storage account is nothing but to store all your files and data, everything during your transformations, the data ingestion. We have two varieties of storage accounts, blob storage and data lake storage Gen 2. We'll go there in detail once we get into the classes. Okay. So for now, just restrict to it's a kind of a storage where we can contain all the folder structure, we can create everything. So let me create some kind of a container. So where I can name it as raw container. So it's within a raw. One second. It's a blob storage again. I'll tell you how to differentiate between the blob storage and the data lake storage Gen 2. Once you create the storage account, right? So if you go to the overview, hierarchical namespace is disabled. So in this case, it is disabled. So it is a blob storage. If it is enabled, it becomes data lake storage Gen 2. That is a slight difference, but capabilities are too much difference between this data lake storage Gen 2 and blob storage. For now, we will go with the blob storage only. Okay. So this is the raw. In blob storage, we can only create one high level, create one folder and different files. We cannot create nested directories. That is one of the major difference. Okay. Raw. And again, I'm going to create another container, something called land. Okay. So we'll try to access this container from the raw, take this txt file and copy it to the land using the ADF. So that is the one we are trying to achieve it. So it's a TST file, not CSV in our case. So it's a simple use case, but I will try to show on the demo. Okay. So for this, what we need. So as I told you, right, we need pipeline, we need copy activity, we need data set, we need link service. Try to create all these things one by one. Okay. So we have a pipeline. So let me try to drag it. Copy activity. I might be fast. Let's try to understand. Later we'll go and discuss in detail post this call. Okay. Okay. So source. So I told, right, source, we need to identify the data set. Right now there is no data set. I'm going to create because it's a type of blob storage, right? Based upon, and right now it's a binary file, text file, right? I will select only the binary. So this is created data set. So I created that this data set is the kind of a blob storage where this is the format, but link service you need to create for constant string, right? So for that, go and create the link service. I'll keep the default names. I will keep this is important thing, auto resolution runtime, right? So this is where the actual runtime will come here. Right now we'll go with account key. I'm not going key vault at this point in time, and select subscription should be like Freetail or what we have. Storage account, the blob storage which I created. So something I can, this is the connection, right? Let me test the connection. So once it is success, so that it can able to connect to that particular storage account, it could be ready for the usage via ADF with the help of integration runtime. It's taking time. Second. These changes, why it is taking time, I don't know. Just wait a minute. Usually it will not take this much time. I don't know why. Network issue. Yeah, in between any question until it completes. Any of you have some idea about all these services so far? What we discussed, anyone tried actually?
Yeah, actually, I have tried. Actually.
Who is this?
So,
Satish?
Hari Krishna.
Hari Krishna. Yeah. Tell me, Hari, what you tried actually? You are from Power BI kind, right? Okay, Power BI.
Yes. Actually, I was working with this. Recently, I received a project to support ADF. So
Okay.
when I was looking on it, I got to know something about it.
Yeah. Connection successful. Yeah,
Yes,
we'll come there. Yeah, we'll come there, Hari. Okay.
Yeah, cool.
I thought of interacting during this time. Okay. So where we have this link service and we need to give the container path from where, right? So from raw, right? From raw, there is a file. We need to select that file. Okay. Similarly, so now source is completed. Similarly, go for the sync. Here also we need to create the data set. So here also it is a blob storage. Again, I will put as a binary. Okay. Again, same link service we can use because it's same entity only, right? No need to create another link service. Until unless your connection strings pointing to the certain storage account or system, right? You can reuse the same thing. The only matter change about container path will keep change. It is raw, now it is a landing. That's it. If you have any other folders, we can select there also. But right now there is no folders for us. Okay. So that's
I have one question.
Yeah, who is this?
Satish.
Yeah, Satish, tell me.
While loading the data from source to landing, we are not doing any transformation logics, or we're directly simply dumping.
It is just ingesting the source data as it is. Because many of the use cases right now, right, we are working on the ELT thing. In this case, yes, there is no transformations. But if you want to make the data, raw data in one container, from there you start doing the transformations using the data flow. That could be the best practice we used to follow.
Oh, okay. And one more thing, means how we are splitting the columns here.
Yeah, we will come there actually. So that's the capabilities we have it in the data flow. That's what we have not here, right? In data flows, we have that derivation, new columns, everything, the format, everything. We can achieve it using that one. So here it is. 1 second. There is a mapping. Mapping is 1 second. Mapping and support for mapping. This is a binary copy, right? It is not supporting. Usually there is a mapping field will be there from source to target. If it is based upon the database, if it is file to tablet, here we can do that mapping. So we will go there once we get into the use case, that derivation of the columns. I think you are looking about how we want to derive some new column based on 2 columns, how to map this source to target mapping, right? That's all you're looking, right? Something called arrow mark. Yeah, it is available in this mapping. But right now it is a binary data, it is not supporting. That has capabilities here in copy, as well as in copy also we have that capability. In data flow also we have that one more in way to answer you. Okay. Fine. So right now I've set up all these things. So without creation, if everything is available in the Azure cloud, in your public cloud, there is no need to create the integration runtime. It will be available. I'll show you default integration runtime. Okay, this is called auto resolve integration runtime. This will be available. This is kind of a PaaS service, right? Which we are trying to say. You need to develop everything. CSP will take care of. When I say CSP, Azure cloud service provider will take care of all this runtime integration runtime setup, everything. But if you want to exclusively create an integration runtime from on-premise database, we need to identify the proper integration runtime to start with this. So for now, there are options called because publish all will try to make your changes permanent in the data factory. But if you want to do without that, some debugging, right? So let's do kind of a debug. Some debug will run and give output also. See, right now there is a raw text is there, and landing there is nothing. We have set up everything. 1 second. Let's debug. Okay, first debug. So debug will this will be give the status of this output. I think it is queued. Yeah, it is completed. The integration runtime used is automation run. This is a run ID which we can use it for tracking purpose. So if you go there, 1 second. My screen share is gone.
Yeah, it's gone.
Okay. Right now, I just reshare by mistake. Okay. So, sorry, what happened? Reshare again. Okay, I'm just by mistake I'm clicking stop shares. Okay. So this is the landing. So we got all from raw this to raw, right? So simple use case. Just I want to show that how it works. So this is the way copy activity will just dump the data from source. Many of the real-time use case, right? What is happening right now? We are moving into from ETL to ELT. There's a slight difference about architecture because earlier and all we used to identify a lot of time in extracting and transform load. Right now we are not doing that actually in the modern data warehouses, data solutions, right? We are trying to dump everything in one data lake. It's a cheap storage. From there, whatever need we want, go back and do the data lake. From there, we are going to do all this transformation, everything. So that in every project, we have this kind of requirement to ingest the data as is into the cloud. So that's where we are trying to show you this use case. So this is a kind of a one of the step we do in the ELT kind of architecture. ELT is just extract, load, and transform. With this, what we can achieve, right? We can bring the data. We will not do complete analysis on the complete set of data. Wherever the use case requirement, we'll go back and do the transformations and load it. So in a way, it will give a lot of value to the business when compared to the old traditional ETL technologies, because it will require a lot of time in transformation. Without transformation, they will not even load it into the target. But here we can load it in a raw format. We can take the subset of data based upon the need, because some data may be required for the business reporting. Some data may require data scientists to do some models. Some data may required for the data analyst to do some kind of a descriptive analytics. Some data required for the reporting for the CEOs. So based upon identification, we will not lose any data once we bring it to the data lake, right? So that's where the proper we are creating a data lake. Now world is moving towards data lake on top of data lake. That is a new capability altogether. That is not the beyond this scope, but I'm just letting you know based on my experience. So here we are able to see the moment using lively copy activity. So let's go there, understand, monitor how it works. I'm telling you, right, this particular pane which will give you that view about the how your data factory pipeline runs. So here we can achieve. So right now ours is a debug, right? So we have run through debug mode. That's the reason it is available in the debug. If it is triggered via triggers, right? We have a option called trigger to trigger the data flag, because in project we will not do in this way. We will try to orchestrate everything using dynamic parameters, and we will try to add these triggers there based upon the need of the required. We have predominantly 3 varieties of triggers where we can schedule it so that automatically it will run. So based on this, we can check in this monitor. These monitor outputs, we can move it to further to any storage account for the analysis and to do some kind of a reporting or analytics, or we can also create some alerts, everything based upon the failures or something to want to send message. So manage is a kind of giving a view about the link services, what we created during our flow. We created one link service. Similarly, integration runtime is a default. Azure Purview is a different capability that is beyond this scope. That is a data governance tool. It is more getting popular. And Git integration, Git configuration is for the putting your code into Git ADF. ARM templates is predominantly to, because when you do the practice or when you want to export all this code into JSON format, we can export, and once we create the data factory again, we can import it using ARM template so that we can save our code if required. Similarly, triggers, which I told you, right? We have a kind of a triggers based upon schedule or a trembling, or we have event. Global parameters is something we can create the parameters to make use of the global and customer manage key credentials. These are this related to the security. So most of our work will work based upon these kind of areas only with this studio, and we'll be taking this requirements and we'll building this pipeline. It is very simple. Like this, we can chain all the activities. These are the activity. So like this, if someone want to copy, as Satish mentioned, Ram, if I want, or if you want to do the transformations, let's go there, do some transformations, right? In that, what we do now, let's go to the data flow. Okay, we can create this data flow similar like other tools only. So based upon this success, we can try to build this kind of a chain activities, whatever. Like this, we can achieve it. Data flow, we can further go and identify what capability, what we can add it. So like that, based upon once if data once after copy, some transformations is done, I'll keep it here, and after that I want to do some kind of a general checks like if it is pass or a fail, something, right? Condition. Okay, I can still put if. Like this, after transformation, if you want to true to do something, and to further, if it is false, you can, like this, we can chain it everything. So we can, if you want to change this structure, we can use this one, so it will become like this. So like this, we will be going, keep on creating these pipelines, and we'll be adding the activities, and we will do everything. So once if you do everything, you need to publish all. So this will make your changes permanent. Right now there is error. I know the data flow I have not set up, but I'm just letting you know, without publish, changes will not go into the save as a permanent. So you will be losing the changes. So we will do debug just to ensure that it's working perfectly or not. Based upon, once you are happy, you can go with the publish all. The moment if you start using data flows, we need to use the data flow debug. Behind the scene, what will happen, right? Data flow, it will use of the Spark capabilities where the computation will be given. It will run you will be not knowing, but behind the scene, everything will be taken in the using through Spark clusters only, the execution part. So let's go back to the